Dr. Rhonda Patrick here. Today we're going to discuss the similarities and differences between krill oil and fish oil. Omega-3 fatty acids, including eicosapentaenoic acid, also known as EPA, and docosahexaenoic acid, also known as DHA, are extremely important for human physiology. In fact, because fish oil is already one of my most favorite supplements, it's been really hard for me to entertain the notion that there may be something even more awesome out there. Omega-3 fatty acids are essential fatty acids that are required by the human body. They must be obtained by diet because our bodies are unable to make them. In fact, data from the National Center of Health Statistics has shown that omega-3 fatty acids are one of the top dietary factors that influence early mortality. But before we dive into a comparison between krill oil and fish oil, let's go over a few of the established benefits of omega-3 fatty acids. Supplementation with EPA and DHA has been shown to lower all-cause mortality. It's been shown to slow the attrition of telomeres, which are a biological marker for aging. It's been shown to delay brain aging by helping the brain repair damage as well as delay brain atrophy. It lowers inflammation, which causes tissue damage as well as plays a role in cancer. It increases HDL and lowers triglycerides, and it plays a very important role in cell membrane fluidity, which is critical for neurons because the important function of neurotransmitters depend on cell membrane fluidity, including neurotransmitters like norepinephrine, which play a role in focus and attention. So whether or not we're talking about mortality or the awesome effects on delaying brain aging, omega-3 fatty acids are pretty great. But that's not what this video is about. We'll dive into those mechanisms in another video. Let's get back to the context of this video and compare the similarities and differences between krill oil and fish oil. There are a few key characteristics that distinguish krill oil from fish oil that may influence the way you supplement. The omega-3 fatty acids found in krill oil are more bioavailable. The variety of DHA found in krill oil is preferred by the brain, and krill oil contains a unique antioxidant that's not found in fish oil. What's important to understand about fish oil is that it is usually modified by a process known as molecular distillation, which allows for the concentration of EPA and DHA omega-3 fatty acids and allows for the removal of any contaminants such as mercury. This process of molecular distillation involves taking the omega-3 fatty acids, which are in triglyceride form, meaning 3 fatty acids bound to a glycerol backbone, and converting it into an ethyl ester form, which involves removing that glycerol backbone and replacing it with an ethanol backbone. After the process of molecular distillation, the omega-3 fatty acids can be reesterified into their triglyceride form. However, most fish oil supplements on the market contain the omega-3 fatty acids in their ethyl ester form, which is unfortunate because that's less bioavailable than the omega-3 fatty acids found in triglyceride form. The omega-3 fatty acids found in krill oil are mostly in phospholipids, such as phosphatidylcholine, phosphatidylserine, and phosphatidylethylamine. Phospholipids contain a fat-soluble diacylglyceride and a water-soluble phosphate group that's attached to an organic molecule such as choline or serine or ethylamine. What's important to understand is that the omega-3 fatty acids in phospholipids are more bioavailable than the omega-3 fatty acids in triglyceride. Omega-3 bioavailability is heavily influenced by how it's absorbed in the small intestine. In order to be absorbed in the small intestine, EPA and DHA from fish oil, whether in triglyceride or ethyl ester form, must first be cleaved by pancreatic lipases, which are enzymes that cleave triglycerides, into their free omega-3 fatty acid form, which means they're no longer bound to a glycerol or ethanol backbone. The omega-3 fatty acids found in krill oil can also be cleaved by another class of enzymes known as phospholipases, which cleave phospholipids. However, it's important to note that phospholipids don't necessarily have to be cleaved because they can also form micelles and can be absorbed in their intact form. Ethyl esters are very poor substrates for pancreatic lipases, and for that reason, they're not absorbed very well in the small intestine. Omega-3 fatty acids found in triglycerides are more bioavailable than those in ethyl ester form. However, they are not more bioavailable than those found in phospholipid form for two reasons. The first reason is because the gastric lipases in the stomach can break down omega-3 fatty acids in triglycerides. This is not the case for phospholipids. And the second reason is because phospholipids don't necessarily have to be broken down in the small intestine. They can be absorbed in their intact form. There's evidence demonstrating that the omega-3 fatty acids from krill oil in phospholipid form is more bioavailable than fish oil. Mice that were given identical doses of EPA and DHA in either phospholipid, triglyceride, or ethyl ester form had EPA and DHA plasma concentrations that were highest from those in phospholipid form, followed by triglyceride form, and then lastly by ethyl ester form. In line with this, humans that were given doses of krill oil 38% lower than those of fish oil had the same levels of EPA and DHA in plasma as those given fish oil, despite the fact that they were given a much lower dose. So all of this data suggests that the bioavailability of omega-3 fatty acids is higher in krill oil because of the phospholipid form than that of fish oil in either triglyceride or ethyl ester form.